see my screen?
In the edit format, if you will.
Yes. I'm just gonna do the presentation format. Okay,
And
so the presentation title is to assess the microclimate effects and irrigation water requirements of three different types of landscape, including mesic, oasis, and xeric landscape. This was a collaborative study between Dr. Ariane Midel from ASU, Dr. Harun Steven, and Dr. Sajad Ahmed from University of Nevada, Las Vegas, and me. So the objective of the study, if I can, huh, not moving. Sorry. So the objective of the study was to understand the diurnal changes in surface temperature, air temperature, and irrigation water requirement of three distinct landscape in arid climate. Um, and to give you a background of what mesic oasis and xeric landscape entails in the study, um, mesic landscape we define mesic landscape as high water use plants that were irrigated through sprinkler system. Oasis landscape was kind of a cocktail between high and low water use plant, and it was irrigated through drip and a sprinkler system. Drip when we were seeing shrubs and um, trees and sprinkler system because of a patch of a grass that we found. Um, Xeric landscape, it was defined as low water use plants, and those were irrigated through drip system. And we're here, I mean, I'm showing you three different type of pictures, as in mesic, oasis, and xeric landscape. Xeric being the shrub and tree, which is this picture, oasis, mesic being the turf, having the turf in there. Therefore, this picture, even though it may not be the perfect mesic landscape example, and oasis landscape having palm trees, shrubs, and a little bit of grass here and there. Um, so yeah, high water, as I said, high and low water use plants. We picked our study area as North Desert Village neighborhoods, mainly because those were designed by Central Arizona Phoenix Long-Term Ecological Research Group, and the um, the reason it we chose that was it was there were already a lot of studies going on to kind of measure the temperature, have a plant inventory as to how they behave, and what is the plant soil water interaction, leaf area index. So the model that we chose to kind of use for the analysis was data intensive and required a lot of details, the profiles of the soil within 300 meter and all of those things. And uh, we just had that information because of the ongoing research programs at CAP LTER group. So that's why we decided these three neighborhoods. And um, so this is how we model the neighborhood. These are the three-dimensional landscapes. Um, the one over here we modeled was xeric landscape, where you can see the trees, and these gray areas are the houses around it. Oasis landscape had high canopy, as you can see, with trees and a little bit of grass. And then mesic landscape was, of course, tree turf landscape, which means that it was covered with, as you can see over here too, covered with the grass and trees. Um, these red dots are the stations, urban stations that were in, or climate stations that were installed on land, these three landscapes to kind of calibrate the air temperature values, and we used it to validate our model too. Um, so we used the NV simulation model, which kind of is a soil building atmosphere interaction, and it works on the principles of surface energy budget. So what it does is you have to define each and every pixel or each and every grid on the NVMet, and based off of um, the amount of sun, the albedo that you are giving to the model, and then the interaction of that albedo with the surrounding, whether it's tree or whether it's build surface, it develops a long wave emission profile and the short wave emission profile, and then the surface temperature profile at 20 minutes interval, I believe, and the simulation run can be as long as 48 hours. So for this reason, we were only able to kind of simulate the hottest day of the year in 2011, because that was the data that was available to us. So the computational steps undertaken in this study there were like four major computational steps. We set up our model, as I discussed, using NVMent, but there were still five major steps within that setting up modeling. The first one was to digitize the actual site. This is the step where we defined the plants, the houses, their material, what type of albedo were giving to the walls of the houses, inside temperature, outside temperature, all these things were defined over here. Second step was to allot the time step. We went for a 20 minutes time step for 48 hours, but because of we did not consider the first 6 hours or the last 6 hours in order to kind of give a model enough time to stabilize throughout the simulation. Even then, we only picked one day because the other day was not really completely um, present. Third step was to prepare the meteorological data, which we got from the ASMET website. Fourth step was to prepare the simulation file. I prepared the simulation file by putting the meteorological data, putting the digitized map, and then forcing there were some steps involved that that gave us option to either select the soil profiles and include that, temperature profiles and include that. So we considered all of those steps, and then we extracted and analyzed the spatial maps that in the end the simulation file after running gave us. We evaluated our model through four different statistics variables, including the root mean square error, root mean bias error, mean absolute error, and the index of agreement. Um, the purpose was to kind of determine the microclimate effects and the potential irrigation water requirement. We defined our microclimate effects as the changes in surface and air temperature at a diurnal rate with the wind speed spatial variation. We also analyzed our the by in microclimate effects. We analyzed our effects by time series plots and spatial maps at noon time. And I'm sorry, the potential irrigation water requirement was kind of estimated as the function of evapotranspiration and irrigation efficiency. And this evapotranspiration was kind of extracted as a potential evapotranspiration from the model, and the irrigation efficiency we uh, picked from the literature reviews. And based off of there are only two types of irrigation system defined in this study. One is drip and the other is the sprinkler system. Any questions so far? I know this slide is a bit overwhelming. Okay, I'll take it as a yes. Um, so um, just another a little bit more detail about the computational steps. When we were digitizing the study area, we put the building shapes and heights, plants physiological characteristics that includes the leaf area index, leaf area and density, or the percentage of canopy coverage by a plant. We also put the albedo and emission of different covers that includes buildings, pavements, driveways, and all the other hardscapes. We defined our soil profiles based up until 200 centimeter, and after that we just said that all the soil is equal, and it's I believe that the sandy soil, um, based off of the USGS soil profiles that we had for the Arizona. Time step for the model total 24 hours with 20 minutes time step, and we went for the hottest day of the year. Um, we also had an option to select the low leaf area density and high leaf area density in the time step for the model. And we for Xeric and Oasis, we kept low LED, and for Mesic landscape, we went for the high LED model. Um, the meteorological data preparation required maximum and minimum temperature and maximum and minimum humidity, wind speed and direction, and soil temperature. Soil temperature was um, retrieved from the it was retrieved from the CAP LTR group analysis. The rest of the stuff rest of the data we acquired from the airport station weather data. We simulated the landscapes. There is this the icons are actually representing the interfaces of the NVMet, and there is a interface called Leonardo where we can actually generate the spatial maps and do further analysis. So we went through that route to do the analysis. All right, results. Um, the first one is the model evaluation. We compared our generated data, air temperature data from model to the air temperature data of the climate station that is installed in each landscape. I don't know if I can. All right, it might a little too far. Yes, these red dots. We compared. So we picked these cells for the and the air temperature data of these cells where the climate station is, and we also plotted or extracted the climate station value, air temperature value of that station, and then we did the comparison. And turns out that our values are within the normal range of error, which is Xeric landscape had the highest error of all, and it's throughout literature review we have kind of known that NVMed does not really do well with xeric landscapes. I'm not too sure why, but my guess probably is that some of the convective effects is it's not picking up when it comes to temperature, and that's why, but not too sure. Um, yeah, so these are the performance graph, and most of them seemed okay, but xeric landscape had the highest error of all the three of them. And so our surface temperature for Mesic landscape, median surface temperature was 55 degrees Celsius of the neighborhood, and with a tree canopy, which you can see with these orange color, those were 4 degrees Celsius lower temperature than the turf grass overall. So we also observed that building in general, as you can see over here, has a lower temperature than, and trees have lower temperature than the surrounding buildings and the turf grass. For the oasis landscape, the median surface temperature was comparable to the mesic landscape, which is 55 degrees C. But um, We also observed that our lowest range of the surface temperature was 5 degrees C higher than the mesic landscape, which for the xeric landscape, um, this landscape was 1 degree C overall warmer than both mesic and oasis landscape, and we observed minimum temperature in vegetated surfaces, but that was 7 degrees C higher than mesic landscape and 3 degrees Celsius warmer than the oasis landscape.
Rubab, quick
Yes,
question. Is the
sure.
When you say site, is an observation kind of this pixel or this box that we're looking at, or is the observation an individual house?
Could you repeat the question? I'm sorry.
Yeah, so when you were describing sites or observations, like data observations, is it kind of is one observation kind of what we're looking at, where it's a collection of houses? So here it looks like, 6 houses might be the observation in the landscape,
Yes.
or is it per house? Is each house a data point?
So this whole map is the site. Maybe I should stop using observation point. Um, the observation points, the place where you should be seeing observation point is over here, where I picked the one spot and compared the data. But because these are spatial maps and they have a lot of spatial data, that's why I went for a median surface temperature and how the vegetation is different um, than the surface. So I would say that it's the site analysis of the site, not the individual houses inside the site. Does it answer the question? I'm sorry.
It does. Yep. Thanks.
Okay. All right. So about the diurnal air temperature, um, I think surface temperature and air temperature in general have a strong correlation. Maybe the only time it kind of varies a lot is because of convective effects and all. So we found the same type of relationship over here where mesic landscape shows like 2 degrees Celsius higher air temperature than the oasis landscape during peak daytime hours. And then the xeric landscape showed on average 3 degrees Celsius higher temperature than mesic and oasis landscapes, which we can quite observe over here. Xeric is the red line, um, and then Mesic is blue, and um, Oasis landscape is the black line. So as you can see, at the peak time, Xeric has the higher temperature, and then Mesic and Oasis has lower temperature of all, which was a little surprising to all of us because we all were rooting for mesic landscape as it is a tree turf landscape, but turns out that um, because of the height of the trees and how they are breaking the wind in different directions, the coolest landscape was the oasis landscape overall. Um, we also observed the diurnal evapotranspiration and irrigation water requirement, not only inside the landscape, but also within the or between the buildings. Um, the plants that were in between the buildings, we couldn't really found strong correlation between the buildings. We're still doing a little bit more analysis to understand it, but overall, what we found was a pretty straightforward pattern where evapotranspiration rates of mesic landscape were higher than oasis and xeric landscape, and then the irrigation water requirement based off of the depth of the irrigation of oasis landscape was zero point 0.1 meter per hour higher than mesic landscape, and xeric landscapes was zero point 0.5 meter. per hour lower than the mesic landscape. So overall, we concluded that the Oasis landscape was 5 degrees C warmer than mesic landscapes overall. But at daytime, we saw 2 degrees C, 2 degrees Celsius cooling in the Oasis landscape compared to the mesic landscape. We also found Zurich landscape to be 7 degrees C warmer than Oasis landscape. And overall, um, Oasis landscape showed 0.1 meter per hour reduction in irrigation water depth compared to mesic landscape and promised 1 degree C neighborhood cooling at the daytime in median. So those were our conclusions overall. Questions?
That was amazing. And I have like a million questions. And I don't want to take over. So I'm going to let Travis be the moderator. Um, but I just want to make sure that we all understand the results. So can you, what do you think the overall water savings are? So you said like 0.1 meter per hectare. I'm just trying to wrap my head around what this turns out to be in terms of average household water use.
Mhm.
So I think for average water use of the household, if we have a xeric landscape, then we should be expecting probably it's somewhere in my paper too, 50% less water than mesic landscape. Um, Assuming that the mesic landscape is at 50% turf grass and 50% tree on the turf, not outside of the turf. Um, and then for Oasis, I believe it's somewhere between 34% um, compared to the xeric landscape. Does that answer your question?
I think so. I'm just kind of, I want to like, I think about often in terms of how the cities are measuring households water use in terms of gallons per
Yes.
households. And
Well,
so I'm just trying to convert that over to what that means in terms of saving per households. But then but you know, we don't have to dive into that at the moment. I'm just also wondering, um, you're talking about like, so it's warmer during the day, but there's more nighttime cooling because of the higher evapotranspiration, right? So the music
right.
landscape does win in terms of nighttime cooling, which is also something to
Yes.
consider in a very hot environment. But you think it's because of the tree heights that were leading to warmer temperatures in the music landscape during the day. Is that what I'm hearing?
Compared to Oasis landscape, because Oasis was like 2 degrees C cooler, and it's actually its nighttime cooling was also comparable to mesic landscape, which which was shocking, but at the same time it made sense because we also have high water use plants in there who that are doing the evapotranspir that's physical process of evapotranspiration is very much comparable to the mesic landscape, but at the same time they, I think, are doing some sort of root transfer to the low water use plants, or something is going on that is making it comparable to the mesic landscape. But because I think the philosophy in general, and correct me if I'm wrong, I'm no plant scientist, I'm a remote sensing guy in general, or a gal. But the the more, I think that if your soil is moist, your plant is fine. It will have the evapotranspiration rate at its basic level. And because we have these two type of sprinkler system in mesic oasis landscape, our soil stayed moist overall, and these evapotranspiration process was not being affected that much. And I believe it's because of that that we have nighttime cooling comparable to the mesic landscape, or that's the plausible explanation in my head. But yeah, the Oasis landscape was a little surprise to us.
For the sake of this conversation, as other people ask questions, I'm wondering if you have an image of the three landscapes in your presentation that you could just have. I mean, normally I say turn off your slides so we can all talk, but I think it might be good for this conversation for us to see those landscapes. I've personally
Sure.
been there, but Oasis as a landscape type is not something that's common across cities. It is something that I've seen exclusively, mostly in desert cities, like this like description of Oasis. Um, so I think it's interesting for us to like think about what the structure is of these landscapes as we converse about what these results are.
Right. I'm trying to see if I can show you the pictures of landscapes. Yep, these probably are the pictures of the landscapes with our native kind of a native style landscape acted up, so we didn't consider this, but this is how the xeric landscape kind of sort of look like. Oasis was this. This is the grass that we modeled. It's probably like a diamond shaped grass. And then the palm trees and shrubs that we modeled. And then mosaic landscape is this one with tree and turf. I should just maybe, sorry.
I wonder what Oasis would look like in sort of a grassland ecosystem. Would it be lawn and then essentially what looks like xeric beyond it, or like I mean,
It's a really good question, Travis. Like I don't know if I want to go down that route just yet, but I mean it's
like can you
funny
I
how
guess can
these
you only
landscapes have
do
evolved.
Oasis in a
Yeah,
desert?
yeah, totally.
I think,
Um,
yeah, I totally agree. And I unfortunately don't have an answer to this. And but it also triggers the question that do we have enough understanding to kind of even define Oasis? What is Oasis to begin with?
Yeah, I mean, this is why I love Phoenix and all the work that comes out of there. And these oasis landscapes are always fun. And it's funny how you said the native landscape acted up. I'm wondering what you mean by that, because the native landscape is
So these
always
shrubs,
acting up. Yeah.
yeah, these shrubs, they are so tiny that my grid, even though it was 1 meter by 1 meter, it was hard to one model them, two they did not show me the real results. So my results were wobbly, and we're still working on why. So the more surface you show to the NVMet model, the more biases it creates on the on the model in itself. So we decided to not go through the native style landscape because the model was not really predicting it well.
That's what I was going to ask you about how you now that you've used this model. I mean, how I don't know. I've used models before, and at the end of the day, been like, this is okay for some things, but it's junk for other things.
Yeah,
And so I
yeah.
just wondering if you have any thoughts on, do you think NVMet would work, say, in temperate forest systems or temperate systems in, places, other places in the U.S. or around the world, for example, that have different urban sort of structures?
So it was designed for the tropical areas to begin with, and then there were like additions and plugins and all those sort of things. But there has been some recent studies that have shown that it may not be the best kind of software for to use for one um, arid climates because of its some of its assumptions in the model, and two, it may not be. My personal conclusion with this was that more beyond xeric landscape, the sparse the plants are, the wobbly the results are. So after that, it is not really working well. And I think it it's probably related to um, plant, water, and soil interaction versus soil. It's not picking up the flow correctly of
Hmm.
how that changes. So it needs a bigger patch. And after that, if the variation is there, it doesn't act up. I don't know how to explain. I hope I'm making sense at this point. So it works in a
If you're
cluster
not, it's
farm.
only because these models are so convoluted and we're trying to
Right.
figure out what the model says versus what's real life, right? I mean, I think
Yeah,
Dina has a question in the chat about the irrigation efficiencies, which might actually come into play to this
Mm.
conversation. Um, and so like not only just the irrigation efficiency she's talking about, but are you using real irrigation numbers as well? Because so maybe dive into that a little bit more.
I do not use real numbers for the irrigation over here, but that's a good suggestion. I use irrigation efficiency to kind of reach to the irrigation water requirement, and that's where I stopped.
So a
But
lot with the irrigation efficiencies, they're kind of be finicky. There's a lot of literature out there that says this is what the value should be. But that's for like a brand new system that's in the ground and somebody actually knows how to install it. So it's not Billy Bob
right,
Joe just installing some type of irrigation system. So I'm just wondering if some of that might be throwing off your model too. So that was just kind of some of my thoughts. And then
yeah, that's a
yeah.
good suggestion. I should go back and look into that. So because it was installed by the experts and this was a study site, I just assumed that irrigation efficiency should be same. But you're right, I should always double check. That's one thing I did not pay attention to much.
Yeah, and then the other thing is consistency and is everybody watering at the same time? Because
Yeah,
timing of when the water is dispersed against the environment is going to impact it also.
right. I think for these three sites, there was a watering schedules and they were watering all at the same time because they are probably not even a mile away too. So we're in the same irrigation zone or class.
Yeah,
These
and
neighborhoods were built as a experiment. Like
oh,
Yeah,
were they?
it's really, really interesting. This was developed many years ago. I don't know, you probably didn't catch there was a in the beginning of the presentation, there was Martin et al. 2007. When I was a postdoc there, they were like these landscapes were all new and they were designed for long-term analysis, but it was just really, it's really hard to study them. Like ideally, it seems like great. Oh, now you have landscape set up to study, but like it's not as I'm sure you would also say this as well, Rubab. It's like also just not as you think it's amazing until you start working with it.
yes,
So, so do these households not get to decide what to do with their lawn? Like, is the lawn completely managed by scientists?
yes, I believe so. I mean, it used to be. Now I don't think these sites are being monitored as much. The funding's dried out. It was NSF funding, and it has been, I think, 8 or 9 years to this project.
Yeah, and these aren't also
Even
perfect
more.
examples of what an oasis looks like. Like if you look at the variation of oasis across Phoenix, this is a real ugly version of it, quite honestly. And also like the amount of lawn varies extensively in what you would call an oasis. So we always have a hard
Yes.
time when we're evaluating oasis landscapes because there's such a wide variety of what would fit into what's oasis versus music.
Right. I think that's the part that I struggled so much with. I'm like, okay, I'm putting this plant species in Mesic, but at the same time, I'm putting it on Oasis too. So what makes this part of an Oasis landscape and what makes this a Mesic landscape? Is it only turf grass? Is it, you know, because it has the other one has grass too. So there also have been some loose ends even on my side, and then there is just so little of a literature available in Google Scholar or any other interface to define oasis or mesic landscape There are only a handful of studies, so that doesn't help.
Yeah, and so this is what I see looking at your landscapes, for instance, after studying. So I worked with Fort Collins data, and Austin's also worked with some data, water irrigation data along the Front Range, right? What I saw in my study with the city of Fort Collins was that when there were more trees, people watered less. And so because of the shading dynamic, right? When I look at your music landscape, not yours, but Phoenix's, the one that you used in this like little neighborhood, that entire center area is only lawn, but no trees. And is that
Right.
really what a mesic landscape is? Or is a mesic landscape one that provides a lot more tree canopy and therefore can have cooling benefits without all the water costs, right? So there's these like
Right.
little intermediaries in between what's music and oasis.
Well, maybe also, I feel like I say this now and again, but this is, I heard it today too, is that wind matters. And the thing I hear over and over is that trees slow down wind and at some level make our cities a little bit warmer.
Okay, but Ariane's work has shown that that's like people are overstating that in terms of
Yeah,
how people
because
feel in terms of thermal comfort. Go ahead. Sorry.
sorry.
This is so much fun.
So
Can we do
I've
this all
also
day?
yeah, I think I had that conversation with Dr. Bedell, and she, as you said, she said that, and it so it has there is like a threshold. I don't think we have that yet, and I don't want to say it, but after certain meters, that's when wind plays a role, and I don't have that number. I'm sorry, so I can't say it, but and then it has to be a cluster of trees to kind of stop the wind. One tree or sparse tree, the way we see in at least Phoenix or Tempe, does not really help much. Or even in native style, these trees are not going to contribute much in the wind speed, even though they are placed at a higher height. But then a cluster of trees, I don't even see it in this one, may impact, after 5 meter, may impact the wind speed. So it kind of depends on the urban farm too.
Right. And, and I guess as our sort of eastern edge of the Front Range friends can contest freely, often we're trying to slow down the wind anyway.
Yeah, especially in
Yeah, building
Colorado. Jay
slows
has his
down
hand up.
anyway.
All right, go ahead, Jay.
Yeah, I'm wondering if you've run these simulations like under different weather regimes or temperature regimes. So have you done it in the winter? Have you done it in the summer? Have you done it at sort of peak temperatures? And I just wonder like how the magnitude of, if there's an interaction between, say, overall cool daytime temperatures in the winter and the effects of the neighborhood versus peak temperatures in the summer. Do the differences grow, for example, does that make sense?
So yes, but to answer your question, because this simulation was cumbersome and froze my computer like 100 times, I was only able to do it for daytime for like 48 hours of time on summertime, and I am disappointed about it, and I'm working on the winter time, but I just don't have my results yet.
No problem.
So do you love Envy, Matt? Is it like your favorite or what?
No, I think it's just that I have a model now. I want to test it and give my 100% before I kind of am like, okay, I'm gonna write a paper about how nobody should waste their time on if it's these landscapes, and everyone should take it if it's these landscapes. But I need to have that analysis to write that paper.
Oh my God, you're my Christmas present.
I mean,
This is the best.
It's hilarious.
Austin, go ahead and
yeah.
chime in.
Great presentation. Just following up on
Thank
what Melissa
you.
said. So shade is our work we've done with irrigation data has shown shade's really important. Does NVMet control for shade, or can you model shade with it, or did you model shade? from either buildings or
I
trees.
did model. Oh, I did model a little bit of shade, and yes, NVMed does model shades. I don't know if you can see, but this is the impact between these buildings. What I found was that within buildings there is the cooling is oftentimes comparable to if you have a tree, but I don't, it is a 3D model, so you can see the shade underneath, but when you have a spatial map, what it cannot show you is what is underneath this tree and what is the temperature underneath it. So I believe the correct answer is yes and no. Like, it depends on the placement. It can show you the shade between or induced by these two buildings, if the sun angle is somewhere over here, but it cannot show you the underneath pixels of the surface when over a tree or something. Am I making sense?
Sure. Yeah, and interestingly, Melissa, by the way, that paper is about to go into review, finally, and
Oh,
the one
good.
on the tree shade. But we did find that building shade is about 50%, has about 50% more effectiveness in reducing irrigation demand than tree shade. Less porous, I guess.
I think yeah, Litvak also came to
Yeah,
those same Elizaveta. Yeah, yep.
exactly.
So, yeah.
Well,
Congratulations.
Austin, hey, we should talk about this because my students are going to come. I have a student that I'm putting just on landscapes in Fort Collins, and she's going to do Marty and kestrels around homes. And if we could actually look at the impact of shade, that would be excellent.
Yeah, Bob, and as you saw, Bob, I don't know if you were on that Duff's meeting.
I was on it. I was on it.
Bob
I
just
bothered
has
you
the
after.
latest 2020 shade models for the city now.
Yeah. Yeah, this is great. I don't know how we got you on this call, but it's been so lovely to see your
Thank you.
research.
It's my honor. I honestly don't have many people talking about Zurich landscape and Mesic landscape, so this is
Oh my God,
great.
call me anytime. This is my jam.
We have monthly meetings, so which I guess are now on the third, must be the third Friday of the month. So I'll add you to our regular meeting. You're welcome to join in.
Thank you. I appreciate it so very much.
Are you a PhD student? What are you? What's your deal?
I wish I was. I honestly want to do my PhD again. I am a postdoc, a fellow
Oh,
at
no,
Desert
yeah,
Research
right.
Institute.
When you're done with the PhD, you always want to do another one. Okay, so are you a postdoc
Yeah.
with the CapLTR? I missed your credentials, sorry.
Yeah, it's okay. I'm a postdoc fellow at DRI, Desert Research Institute up in Las Vegas
Okay, okay.
Valley. Yeah.
You know, I think one key takeaway is one, continuing these conversations, but also for our like kind of city partners is that we should design more of these scientifically managed neighborhoods.
Yes, please.
Yeah, especially if I
I
never
think
have to mow my lawn. Yeah,
They
yeah.
never
Oh
have
yeah,
to.
we
even
talk
better. That's
about,
right.
oh my God. Honestly, it's 1 a.m. over here and I've never been this much awake. We talk about urban heat island and its effects so much, but buildings also create shade that we can optimize it from by putting our landscapes in a more smart way, but we kind of in some ways don't do it.
You know, yeah, I mean, I suppose also as someone who has a 1960s sprinkler system that doesn't work, maybe I should write a grant to replace my sprinkler system, invite y'all into my yard to both mow and water my lawn.
So yeah, Nevada is coming with the turf grass removal program, and this study actually have gotten a lot of media traction, but um, the the questions in general are like, what is going to happen to Nevada once the grass is gone? And I don't think anything would happen per se to if the grass is gone. I think trees are the one who would create more cooling, but because people think or assume that grass has this much significance, that we are gonna have like a an oven and all of that. So it also makes me realize how little of an awareness there is, at least in Nevada state.
Yeah, I want you to be
And
careful with these things, right? Because
yeah,
there's some research in Sacramento, for instance, that's showing that when you switch to these native landscaping types that are reduced water use, that it all goes to hell. The tree canopy dies and everything gets hot and miserable. And so like literally goes to hell, right? And and I thought we saw in Phoenix some evidence that, and I forget who is doing this, and we were showing these data sets, but that like people water the hell out of their cactuses. And so there's just not this like direct relationship between how much water people use and how much cooling there is. Like people are demonizing lawns, but when I lived in Phoenix, lawns were the best thing in the world. Like I loved lawns. They were the only landscapes that you could actually feel cool in, because it's actually really hard to actually grow real trees. So like also when Phoenix starts talking about tree cover, those aren't trees. Like for the rest of the world, those are shrubs, right? And so we're not really comparing apples and apples. We're comparing apples and oranges. And so we don't want the rest of the world making decisions based on just research that comes out of Phoenix, because they can't grow trees. Sorry. I love all the research in Phoenix. You guys are leading the way. It's just that we have to be honest about what we're studying. We can't call something a tree and mean that we're saying the same things, or a music landscape means the same thing in Fort Collins as it does in Phoenix.
correct. As I said, Mesic, Oasis, people, Zurich landscape. I mean, I was shocked when a journalist told me that it's called zero-scaping, which means zero water. And I'm like, no, no,
What?
that's not what we are doing. That is not what it is. It just means little water. So
That's
everyone has
that's
their
what
own version of. I wanted to be like this over like the interview, but I couldn't. I would lose my job. But I was like, do a little bit research, please.
we are getting rid of the word xeric in our communities because of that zero in xeric. They don't understand it. So we're either
Yeah.
calling it Colorado landscapes, so then it's more native, or water-wise
Uh-huh.
landscapes. But
That's
I just wanted to mention real
smart.
quickly, if there's anything that you need in terms of like irrigation validations or calibrations on your model versus just literature, always feel free to reach out to municipalities. We've got folks that are on hand that do this all day. So
Thank you.
you're more than
Appreciate it.
reach out to Greeley. We'll help you out.
Thank you. I
Yeah, but
appreciate
I
it.
don't think our water efficiencies are going to represent what's going on in Phoenix. Like I think we've got to
They
get her to start working in Fort Collins with us, and then we'll actually measure some of these things.
Actually, water efficiencies are dependent. There's de-used delineation of how much uniformity occurs, and they're actually built into the irrigation type system. So if you're using sprinklers, nozzles, sprays, rotors, drip, each of them have a different irrigation type efficiency. And those then will decrease with time. And so there is some a little bit of play for each of those. I think kind of somewhat uniform in different areas. So it really depends on what exactly is being talked about.
Interesting.
Yeah.
You want to do this now in Fort Collins and Denver, don't you?
I do.
You mean Greeley? You mean Greeley?
And Greeley. All right, we'll just pick some parcels in every city.
Well, I mean, I was wondering
I
if
think it
you
would be
have
interesting.
do you have home water use at all of these sites, or at least how much they're irrigating the common space? I mean,
I
you're
asked
talking
for
about
the
your
irrigation.
water. I was thinking about your model validation, and I didn't see anything that validates its expectations of water use, I guess, or it's
No, we only got the landscape, the temperature values. We
yeah.
didn't really get any irrigation values from them. Um, the only way that we could have gotten those was to have the 2011, but they started um, kind of jotting down the irrigation values in somewhere in 2013. So
I see.
that data was not really useful to us.
Yeah, yeah. Well,
Well, since
Austin
you
has
have-
a
yeah,
city
go ahead.
specific or home specific water data, so you definitely
Mhm.
should come up.
Yeah. So now what I'm doing is that I'm not going through NVMe. The other one that I'm trying to publish is that I use the Planet Fusion data set, 3-meter resolution, model the water irrigation water requirement of plants. I think it was 147 plants, and compared them with the irrigation water use. It's been 6 months and we cannot understand why the irrigation water use in some months, especially in winter, is almost to zero, when our model saying is that irrigate 20% more than zero. And then in fall and summer, some houses are like irrigating it to 125%. Other houses are irrigating it 25%. So I think comparing our model value with the irrigation water use was a bad idea, is what we are realizing, because there's just no any corroboration, as you said, that it's not a function irrigation, like saving water, it's not a function of irrigation water use, or irrigation water requirement is really not a function of the way people use their water or irrigate their lawns. But it's interesting how they are irrigating their lawns. One house differs, even if they are in the same neighborhood. One house irrigation pattern is entirely different than the other house. Um, and there is no any distinct pattern. There is no any bell curve when it comes to irrigation water use, at least in our data set in Las Vegas Valley. So it's a multi-dimensional model is what we are realizing.
That is brilliant. Since you have this up though, your xeric landscape, your graph, I thought it shows that air temperature that the model was representing well. What am I not seeing? Like, I mean, I see that the error.
I think there is a typo in this one
Okay,
that I did
because
not
the
fix or
graph,
something.
yeah, the graph doesn't match what.
So this should have been fixed in my.
Well, just letting you know, I wasn't really sure what was happening there. You don't have to. We're not trying to proof your data set. I just like what you were telling me was happening didn't seem like was what I was seeing in the graphs.
No, I totally agree with you on that. As to this one has a higher deviation, but the RMSE is kind of giving me lower point. So I need to go back and see if I made a mistake in my table or over here. I do
Yeah.
those things a lot, so that's why I'm not really confused at going back to. Okay, these are the. Nope, they are the correct ones. The ones that I've reported over there. Okay, that is a good observation. I'll go back and check what I missed over here.
Yeah, it's interesting.
I'll just kind of point out that we're at the end of the hour, and if it's 1 o'clock in Pakistan, so people are welcome to either drop off without feeling guilty or stay on if y'all want to continue the conversation. I'll leave that a little bit up to Rubab, I think.
You can go
Thank you,
and go
Travis,
to sleep.
Thank you so much, guys. It was nice meeting you. Please do add me.
I certainly will. Certainly will. Yeah,
right.
and thanks
Contact
everybody
us
for joining
anytime.
in.
Thank you
Thank you,
all.
Rubab.